A newly detected planet may have conditions more favorable to life than Earth itself, and NASA took too long to talk about it. Why? You're about to discover data that has been ignored for years, and now raises a disturbing question. What if we're looking at the most habitable world ever observed, and it's not ours? This video will reveal what the James Webb Telescope has revealed about this planet, and why this discovery could rewrite everything we believe about our place in the universe. Comment. Now, if science has discovered a planet better than ours, what do you think this means for the future of humanity? And get ready, because in this video, you'll understand what's behind the signs that science almost ignored. In 2015, the Kepler Space Telescope detected an orbital anomaly in a distant spot in the constellation Leo. This spot was K2-18b, a planet orbiting a red dwarf star called K2-18, located 124 light-years from Earth. Kepler, which had already discovered more than 1,000 exoplanets, noted this world as potentially interesting, but not particularly noteworthy at the time. What caught the eye was its position right in the habitable zone, the ideal distance from its star for water, if it existed, to remain in a liquid state. A technical detail, but with gigantic implications. 2 years later, in 2017, the Spitzer telescope entered the scene. Its more refined measurements confirmed that K2-18b was not just a moving dot. It had a density consistent with large-scale water planets. The hypothesis: it could be an ocean planet. Around the same time, data from the HARP spectrograph operating in Chile suggested that its atmosphere was thick and rich in volatile compounds, an indicator of active dynamics, which in scientific parlance means something is happening there. In 2019, Hubble detected water vapor in its atmosphere. It was the first time this had been identified on an exoplanet in the habitable zone. That finding alone already made K2-18b one of the most interesting targets in modern astronomy. But it wasn't until the activation of the James Webb Space Telescope in 2023 that the pieces began to fall into place with almost unsettling precision. Webb detected unusual chemical compounds, including dimethyl sulfide, an extremely rare gas outside of Earth whose presence suggests active, complex, and previously poorly understood atmospheric processes. K2-18b is about 2.6 times the radius of Earth and about 8.6 times its mass. That classifies it as a sub-Neptune, but its close orbit around a small star, combined with the moderate heat it receives, creates an unlikely balance, neither too cold nor too hot. Its year lasts only 33 Earth days, and yet it appears to be stable enough to sustain a dense, chemically rich atmosphere. The question scientists are now asking is no longer, is there something out there, but why does this planet have such ideal conditions in such an unlikely spot in the cosmos? There's a statistical reason why such worlds are rare, but if K2-18b represents a pattern rather than an exception, the way we classify habitability may be completely outdated. And what that implies goes far beyond planetary science. In April 2025, the James Webb Space Telescope trained its sensors on K2-18b in a new configuration. Now operating in the mid-infrared range, a spectrum capable of identifying molecular compounds with extreme precision. The goal was clear: to confirm an anomaly that had been recorded months earlier but had not been confirmed by any other instrument. When the data arrived, scientists were hesitant. What they saw wasn't just unusual, it was too statistically improbable to ignore. Webb had detected dimethyl sulfide, or DMS, a volatile compound that on Earth is found mainly in oceanic environments and in specific biological processes. Its existence outside our planet has always been considered theoretically possible, but unlikely at detectable levels. However, in K2-18b, it appeared with an unexpected intensity. The estimated concentration was up to 1,000 times greater than that observed in the Earth's atmosphere. The first reaction was caution. A reading error, interference, spectral noise. To eliminate these possibilities, the analysis was repeated using different algorithms, using cross methods. The result remained. The spectral pattern was stable and unmistakable. There was DMS in K218b's atmosphere and in sufficient volume to indicate an active, ongoing source. But here's where the discovery becomes disturbing. DMS is highly unstable when exposed to light and oxygen. It degrades within days if it is not constantly replenished by some dynamic process. On Earth, this replenishment is almost always linked to the action of marine microorganisms. In K218b, the mechanism remains unknown. There is no way to pinpoint its origin, but the quantity and consistency of the detection raises a scientific dilemma. Either we are facing a new class of atmospheric processes that we do not yet understand, or something there is actively, continuously, and massively producing this compound. The very behavior of the molecule in the chemical environment of K218b is still a mystery. It is there in improbable proportions on a planet that defies statistics. And the entire theoretical framework of astrobiology is now faced with an uncomfortable unknown. If this substance shouldn't exist there in a stable form, then what's sustaining its presence? The answer may lie directly in the deep chemistry of K218b's atmosphere and the kind of environment it's keeping alive, even if we don't know exactly how. Imagine a planet shrouded in an atmosphere so thick that the light from its star barely reaches the surface. On K218b, the sky is not blue. There probably isn't even a visible sky as we know it. The thick layer of hydrogen and volatile compounds creates an opaque filter, turning the light into a constant gloom, muffled by gases that distort vision and sound. The planet, classified as a Hycean, is covered by a global ocean. There are no continents or islands, just an endless sea, but this ocean is nothing like ours. It can be as deep as 100 kilometers, nearly 10 times deeper than the deepest point on Earth. Below the surface, the pressure would be so intense that it would crush any human equipment in seconds. Under such force, water does not behave like a normal liquid. It assumes intermediate, dense, and highly energetic physical states in which molecules rearrange themselves into unstable patterns. What if we were there? It would feel like being trapped under a dense, invisible mass. No visible landscape, no horizon, just a constant feeling of heaviness and isolation. High temperatures, reactive chemicals, a total lack of solid ground. If there is any form of life, it would need to survive in an environment with almost no light, where adaptation is not an option. It is the only chance for survival. The atmosphere acts as both a prison and a shield. It blocks out intense radiation from the star, but it also traps heat at levels that could turn the ocean into a toxic cauldron. This unstable equilibrium is what makes K218b so intriguing. It is an extreme environment, yes, but stable enough to sustain ongoing chemical processes. And this stability amidst chaos is what raises more questions than it answers. If you could observe K218b for just 10 seconds with your own eyes, what would you expect to see on this world hidden by toxic clouds and endless oceans? Comment below. What do you imagine the landscape of such a planet would be like? Your theory may be closer to reality than it seems, but what is really keeping this environment functioning under such pressure? There is a combination of elements on this planet that may be simulating something much larger, perhaps even rarer, than any form of life. What if K218b isn't just an exotic planet? What if, for all its weirdness, it's actually a more balanced environment than Earth itself? It seems counterintuitive, but scientifically, it's not out of the question. The data indicate that the amount of heat the planet receives from its star is surprisingly similar to that radiated by the Sun to Earth. The star K218 is smaller and cooler, but K218b orbits much closer. This creates an unexpected thermal equilibrium, enough, perhaps, to maintain a stable temperature over time. The absence of continents and the predominance of a global ocean could be another factor in stability. On Earth, land masses interfere with weather patterns, intensify hurricanes, and amplify seasonal changes. On K218b, the even distribution of water and the thick atmosphere act as an insulating layer, smoothing out extreme variations. This could result in a constant climate, without harsh winters, scorching summers, or destructive storms. A planet without seasons, but with energetic stability. Now, compare this to Earth. Here, we live under constant threats: climate change, melting ice caps, severe droughts, tsunamis, cyclones, earthquakes. Our planet is beautiful, but unstable. Every natural cycle can at some point become a catastrophic event. On K218b, however, everything indicates that the climate system can operate within a safe range, supported by an atmospheric structure that, although hostile to us, may be perfect within its own ecosystem. This doesn't mean that living there would be possible, but it does force us to reflect. Earth is unique to us, but it's not necessarily perfect. The idea that a more stable planet could exist, even in extreme conditions, forces us to rethink what we call habitable. It's not always the similarity to Earth that matters, but the internal logic of balance that world builds for itself. But there is a condition on K218b that, if confirmed, would call into question our entire definition of habitability, something that the very structure of the atmosphere may have been hiding all along. For years, the scientific community followed exoplanet observations with a clear expectation. Any unusual signal would be treated with maximum transparency. But when data involving K218b began to circulate among select groups of researchers, something went wrong. The information did not appear on public science channels. There was no conference, no immediate official statement, just silence, followed by a technical note months later. After pressure from other institutions, insiders suggest the data was recorded by one of the most sensitive instruments on the James Webb Telescope. But instead of becoming part of the mission's open database, it was temporarily classified under restricted review. This is unusual. NASA, while cautious, rarely withholds significant biosignature findings. The official explanation was, out of caution, to avoid premature interpretations. But some scientists involved suggest another possibility. The pattern of readings was so out of the ordinary that there were concerns it was a catastrophic error, or something more serious. The situation became even stranger when parallel observations by partner universities were in part redirected or postponed. One of the groups that was to analyze additional spectra was informed that other mission priorities had changed the schedule. Coincidence, or a deliberate attempt to delay cross-checking? In the world of astrobiology, any evidence suggesting unnatural chemical activity triggers a domino effect. If there is life, even if it is microscopic, the implications are profound. Philosophical, religious, geopolitical, economic. Control of the narrative becomes as strategic as the discovery itself. And in this case, it seems that someone chose to hold on to the information as long as possible, until it was no longer viable to ignore it. But what could make this revelation so sensitive that it needed to be hidden? There's a detail in the planet's orbital patterns that previous models didn't account for, and now it's raising an unsettling suspicion among astronomers. Scientists are divided over the detection of DMS on K218b, and it is precisely this impasse that makes this story so fascinating. On the one hand, There are explanations that do not involve life. They suggest that atmospheres rich in hydrogen, compounds composed of extreme chemical reactions, can spontaneously generate DMS. On certain gas planets, reactions involving heated rocks, stellar radiation and volcanic gases can produce complex molecules without biological activity. This is a serious line of investigation, creating laboratory models that mimic the pressures and temperatures of extreme environments and still reproduce traces of DMS. On the other hand, some argue that only microorganisms would be capable of maintaining such high concentrations. But here a dilemma arises. Laboratory data still cannot replicate the levels observed even under similar pressure and heat conditions. If geological processes are the cause, there would have to be intense activity. For example, active underwater volcanoes or permanent hydrothermal vents. And even then, it would be difficult to justify concentrations 1,000 times higher than those on Earth. This contrast creates an impasse that defies simplistic models. Furthermore, there is always the possibility of measurement error. The team warned of interference from spectral noise or confusion between DMS and molecules with similar spectra. But repeated and cross-tested tests over different times and with different equipment continued to reveal the same pattern. If this was a glitch, it was a persistent one that prompts scientists to rethink the planet's current atmospheric processes. This clash between purely chemical explanations and the hypothesis of a real biosignature exposes a deep intellectual divide. It is the kind of moment when science comes face to face with absolute mystery and where apparent truths begin to reveal their own cracks. If you feel the weight of this uncertainty and want to see more serious investigation into the mysteries of the universe, leave a comment like. This way, more people interested in this type of content can also find the channel and strengthen this research community. What if this division of ideas hides something bigger? A subtle clue that connects K2-18b's atmosphere to as yet unexplained cosmic patterns. The universe may be delivering something much bigger, and you're about to find out. Imagine for a moment that all the analyses are confirmed, that the data on DMS in K2-18b are consolidated with 5 sigma precision, that the presence of this highly unstable compound can only be sustained by an active biological process. In this scenario, we would be faced with something unprecedented in human history, the realization that our planet is not an exception, but just one variation among many possibilities for life in the cosmos. This confirmation would not only break down philosophical and religious barriers, but would require a profound restructuring of the way we look at the universe. Humanity would cease to be the center of the cosmic narrative and become just one among trillions of natural expressions. The idea that life can arise where there are minimal conditions, even under colossal pressures and in atmospheres that we would never imagine habitable, reconfigures our scientific arrogance and the perception of the rarity of life. But there is another implication. If a planet like K2-18b, with atmospheric stability, fewer climate catastrophes and no human warfare, is home to resilient and organized life forms, what could we learn from this? Our own climatic, social, and ecological imbalances seem even more fragile in the face of the possibility of extraterrestrial ecosystems that have evolved in harmony with an extreme environment. The question is not just about searching for life beyond Earth, but about understanding what makes life possible and how it can be preserved. Confirming the existence of organisms on another planet would also reveal something disconcerting. We are not unique, and perhaps we never were. The vastness of the universe would not be a lonely void, but a shared stage for cosmic experiments. The question, are we alone, would no longer make sense. And so perhaps the more relevant question becomes, how are we going to behave, knowing that we are not the only ones? But before you jump to any conclusions, There's a hidden detail about the conditions on this planet that still puzzles scientists and could change everything we thought we knew about the birth of life anywhere in the cosmos. We've been chasing answers for millennia, probing space, questioning our origins and the meaning of existence. But are we truly prepared for what may lie ahead? K218b offers us a silent provocation. The universe is not only vast, it may be vivo in ways we cannot understand. This possibility, scientific as it may be, carries an unavoidable philosophical weight. It's not just about detecting an exotic molecule, but about facing the idea that Earth may not be the only home of life, just the only one aware of it. That makes us special, not because we're alone, but because we have the ability to look up at the sky and ask, what if the real mystery is not what lies beyond Earth, but why we are here? Now, with the technology and intelligence to ask these questions, you're part of a rare group of people who are genuinely interested in questions that defy common logic. So share this video now with that friend who also gets excited about the mysteries of the universe. Let's expand this conversation, because the more minds that think about this, the closer we get to understanding what's really out there. But before we close this journey, there is one last truth, one perspective that is perhaps the most disconcerting of all, and it is waiting for you now, at the close. If you've made it this far, it's because you feel the same inexplicable call that moves the great curious of the cosmos. Here, each video is a new frontier. Subscribing to this channel isn't just about activating a button. It's about accepting the invitation to question the impossible, explore the unknown, and discover truths that science has barely begun to understand. Activate the bell. The universe doesn't wait, and each notification could be the beginning of something no one has ever seen before. And now, if you thought K218b was surprising, just wait until you see what's about to appear on your screen. Click on the next video and continue the journey. Something even more intriguing is waiting for you.